In the upcoming unit, we are going to focus on what are referred to as carboxylic acid derivatives. In this video, we are going to introduce this topic, learning about the various types of functional groups that are classified as derivatives of carboxylic acids. When we refer to a carboxylic acid derivative, what we are referring to when we use that word derivative is it's derived from a carboxylic acid. And what we're saying is that we can do a simple hydrolysis reaction, a reaction with water, in order to convert these functional groups that we are going to be presenting here into carboxylic acid products. So in other words, what we can do is we can react our starting material here, which I will fill in, with water. Generally, in that reaction with water, there is either an acid or a base catalyst to speed up the reaction, and the product of that reaction is a carboxylic acid. A molecule is an RCOOH group, and the starting material for that product is a molecule that has generally a carbonyl group here, with a few exceptions to that, and it has what I'll refer to as LV here, which is a leaving group that is replaced with the hydroxy group OH from water during the course of this reaction. And the leaving group here, I should add, will be a heteroatom of some sort. In other words, it will not be carbon or hydrogen, because carbon-carbon bonds are relatively stable and therefore difficult to break. Carbon is not a good leaving group either. Likewise, hydrogen here, if there's a hydrogen atom here, hydrogen is not a good leaving group either, because once that hydrogen breaks away, it'd be very unstable as a product. And so when we're referring to leaving groups here, generally this atom that's directly bonded to the carbon is going to be either a nitrogen atom or an oxygen atom or a halogen atom here. Those are relatively suitable leaving groups because once they break away, they'll be relatively stable on the product side. So when we are referring to carboxylic acid derivatives, we are definitely not referring to things like aldehydes and ketones that would have a carbon-carbon or carbon-hydrogen bond over here. Instead, we're referring to molecules who have a carbon bonded to a relatively capable electronegative atom as the leaving group in these reactions. So what are the specific functional groups that we should be familiar with that are referred to as carboxylic acid derivatives? Let's go through a list of those so that we are ready to recognize those. In the upcoming videos, what we will do is discuss the IUPAC nomenclature of selected common functional groups that fall into this category of carboxylic acid derivatives. So the first carboxylic acid derivative on our lineup here is going to be referred to as acyl halides. Acyl halides we have looked at briefly before when we were doing Friedel-Crafts acylation reactions. We've reacted with acyl halides. Those were molecules that had an R group here, R being carbon or hydrogen, and then over here was a halogen. So in this I'm defining X as a halogen, making this an acyl halide. So our acyl group here is referring to this portion of the molecule that I'm highlighting in blue. I'll highlight the word acyl there in blue as well. So this is one type of carboxylic acid derivative because we can envision that we could break away this halogen atom leaving group, replace it with water in our substitution reaction to give us a carboxylic acid product out of that nucleophilic acyl substitution reaction up top here. Another representative carboxylic acid derivative is referred to as an acid anhydride. I'll go ahead and write that term out here, acid anhydride. In an acid anhydride, what we have is an oxygen that is between two carbonyl groups. So we have two carbonyl groups, each making a single bond to that oxygen there in the middle. Our R groups here are carbons or hydrogens. And this is our so-called acid anhydride. Now, looking at this, the portion of this acid anhydride that corresponds to our template up top here, where we had a carbonyl group bonded to a leaving group, the leaving group in the acid anhydride is the oxygen atom here that I'm circling, as well as either the left part or the right part of the molecule corresponding to that. So for example, we could think of, in our scenario up top here, we have our R and our carbonyl group in yellow up top left. And that would be analogous to our carbonyl and R group down here in the acid anhydride that I just highlighted in yellow here. So this part of the molecule, our carbonyl group and the R group, corresponds to this part here. And then the leaving group in blue up top here, right here, would correspond to the rest of the molecule here. So this part in blue, we could plug in as thinking of that as our leaving group, what's going to break away and be replaced with the OH group in this nucleophilic acyl substitution reaction up top here. And since the acid anhydride has these two hemispheres, two carbonyl groups, what can actually happen is in the acid anhydride, this right half of the molecule could be that carbonyl and R group, and then we could break this bond here between carbon and oxygen, making this other half the leaving group. So either of these two halves of the molecule could act as the leaving group. The key is that in the case of the leaving group, it's always going to be this carbonyl group, oxygen bond here, this one that I'm highlighting right here, or equivalently over here, that is the bond that's breaking and being replaced with the OH group from water in the nucleophilic acyl substitution reaction, making this acid anhydride qualify as a carboxylic acid derivative. Going on down the list here of carboxylic acid derivatives, the next one we will focus on is the ester. Esters refer to functional groups where we have our carbonyl group with our R group bonded to R being carbon and hydrogen again. The carbonyl carbon is directly bonded to an oxygen, and that oxygen is bonded to another R group, where the R group here has to be a carbon atom in order for that to qualify as an ester. And that carbon can't be a carbonyl group, because if it was a carbonyl group right here, then we would have an acid anhydride instead, because we'd have a pattern of carbonyl, oxygen, carbonyl. Here it's carbonyl, oxygen, and then another carbon atom right here that is anything except a carbonyl carbon. And we can envision this ester being converted into a carboxylic acid by thinking of our carbonyl and R group here, highlighted in yellow, corresponds to the carbonyl and R group here, highlighted up top in our generic example. And then the leaving group, LV, would correspond to the OR group, the O alkyl group here. This would be what I'm highlighting in blue here in your lower right corner, would be the leaving group, what's breaking away and being replaced with OH to give the carboxylic acid product, hence making the ester, like the other molecules we've looked at so far, fit that definition of a carboxylic acid derivative. So we have now in hand, thus far, the acyl halides, the acid anhydrides, and the esters as our three types of functional groups that are referred to as carboxylic acid derivatives so far. We have a couple more on the list here. As we carry on this list, we have the amides, or amides, depending on how you like to pronounce it. So in our amides, A-M-I-D-E-S, what we have is a carbonyl group directly bonded to R, which is a carbon or hydrogen. And then over here, we have to have a directly bonded nitrogen atom that has either carbon atoms or hydrogens attached to it. So I'm going to put R2 there, as R being defined as carbons or hydrogens here or here. So the key for the amide is that it has to have a carbonyl group directly bonded to a nitrogen. So making this amide fit our template of being a carboxylic acid derivative. We have our carbonyl and R group here in yellow in the amide molecule. And then if we go over here to our carboxylic acid derivative, we have that same carbonyl and R group. And then that makes the leaving group of our amide, the nitrogen atom, and the R groups, the carbons or hydrogens that nitrogen is directly bonded to. So I'm going to label this in R2 as our leaving group, LV for leaving group. Going onward, but there's more in terms of our carboxylic acid derivatives. We have, as our next carboxylic acid derivative, a compound that is similar to the amide, which is the imide. I know, all these words start to sound kind of similar. I-M-I-D-E, and what we're referring to with an imide is a nitrogen that is sandwiched between two carbonyl groups. So you have a nitrogen with a carbonyl group to the left and carbonyl group to the right. I'm going to move that word amide a little bit so that we have some space here. This is our imide functional group. We have a carbonyl here. And then we have our R groups, which again are carbons or hydrogens. And then our nitrogen here in the middle to fill its complete octet is going to have a hydrogen there. It would also have a lone pair of electrons, which is not shown and not required to be shown. But this would be the imide functional group. And in the amide functional group, much like with the acid anhydride, we can envision that one carbonyl group and R group is going to go along here with our starting material for the carboxylic acid derivative, the carbonyl and the R group, and then the whole rest of the molecule here would represent the leaving group. So I'm going to put the leaving group here in a blue bracket, like I've been doing all along here. And this would represent our leaving group, where we break this carbon-nitrogen bond here right now and replace that carbon-nitrogen bond with a carbon-OH bond to give us the carboxylic acid product of the reaction, hence making the amide a so-called carboxylic acid derivative. And you could kind of think of amides are to amides, that is A-M-I-D-E-S, are to imides, I-M-I-D, as esters are to acid anhydrides, because the amide is a molecule that has a single carbonyl bonded to a nitrogen. The imide has two carbonyls directly bonded to a nitrogen. Likewise, esters have one carbonyl bonded to an oxygen, whereas acid anhydrides have an oxygen that's bonded directly to two different carbonyls, like the imide has a nitrogen bonded to two carbonyls. So these are our main types of acid or carboxylic acid derivatives that we are going to focus on in this particular chapter. Additionally, for reference, nitrile groups are also generally considered to be carboxylic acid derivatives, although nitriles, rather than having a carbonyl group at all, have this carbon-nitrogen triple bond here that we're seeing in the middle of the screen. They are referred to as carboxylic acid derivatives because when we react a nitrile group with water and an acid or base catalyst, the product of that is that the nitrogen group breaks away and is replaced ultimately with a carbonyl group and an OH group. We saw this reaction a bit in the last chapter where we looked at how we could create carboxylic acid products, and one of the ways was nitrile hydrolysis, where we start with a nitrile molecule, react with water, and I believe we did it with acid catalyst to yield a carboxylic acid product. So this nitrile is also considered a carboxylic acid derivative because even though it doesn't have a carbonyl group here, you can react it with water and an acid or base catalyst to give you a carboxylic acid product. So you should be familiar with and able to recognize or draw each of these functional groups. If I show you a particular structure and I say, identify the functional group in that molecule, you should be able to match it up with any of these types of functional groups. What we are going to continue onward doing in the rest of this unit is we will look at nomenclature of selected carboxylic acid functional groups using the IUPAC system, and then we will get into reactions that these carboxylic acid derivatives undergo. And the reason why we are focusing on all of these carboxylic acid derivatives in a single chapter is because they all follow similar themes of reactions that they will undergo. Much like throughout this slide, we talked about how carboxylic acid derivatives all react with water with acid or base catalyst to give a carboxylic acid product. We'll also see that there are additional similar themes in reactivity that we can follow between all of these different types of molecules. So that's where we're headed in the rest of the chapter.